Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, I want to talk about layout, or in other words, how controls are positioned and arranged on your app's user interface. So my game plan in this lesson is to, first of all, start talking about the two primary elements that are used in layout and positioning. You have the grid element and the stack panel element. As far as the grid element goes, I want to talk about defining rows and columns, and then the various sizing options that you have and techniques that you can use to fully unlock the power of the grid to position your controls anywhere on the app's user interface. And then next, I want to learn about the stack panel. And just for fun, what we're going to do is convert our Pet Sounds app from using a grid layout to a stack panel layout, and hopefully that'll teach us some of the key differences between using these two different elements for layout between the grid and the stack panel. And then I want to switch gears away from layout and talk about events. We'll talk about how event handlers are wired up from both a XAML and C# perspective. So this will be a good lesson. I'm looking forward to it. All right, so what I did was I wanted to start fresh so that we can get back to the original default code that is in the phone application project template. So all I did was I went to File, New Project, opened up the New Project dialog, and I selected the Windows Phone app template, and I left the name alone and just clicked OK, and that's what gave me this Phone App 1. So you should do the same sort of thing. And all I really want to do is just take a look at the content panel, which you'll recall from the previous lessons was simply this grid that was used, that the intent of which is to put our controls into. It represents this area, this large area beneath the application and page names, right? And so we put a button in there, and remember, it took up the entire area. That's what we're talking about now. So the grid element, though, is used for laying out other controls. It allows you to define rows and columns, and then each control can request which row and column they want to be placed inside of. So now in the default main.page.xaml page template, between this opening and closing grid tag, the grid appears empty right now. It appears that there's no rows or columns defined. However, by default, there's always one row definition and one column definition, even if it's not explicitly defined, and these take up the full vertical and horizontal space available to represent one large cell in the grid. Any items that you place between the opening and closing grid tags are understood to be inside that single implicitly defined cell. Another example of a grid that we didn't really use up to now, but it's important, is this layout root here near the very top. And you can see that at the top it actually defines two rows by creating these two row definition elements and setting their heights. All right, we'll ignore what the heights are set to just for a second. There are two rows, and the first row contains this stack panel, and the second row will contain this content panel. Now the stack panel, named title panel, notice how it positions itself or places itself inside of that first row of its parent. It says grid.row equals 0. So it puts itself inside of this row that's defined here. And then the content panel positions itself inside of the second row by setting grid.row equals 1. That puts it inside of this row, okay? So you reference both rows and columns using a zero-based numbering scheme, like you saw just then. The first row here, it has its height set to auto, and the second row has its height set to an asterisk. So there are three syntaxes that you can use to help persuade the sizing for each row and column. I use the term persuade intentionally. With XAML layout, heights and widths are relative and can be influenced by a number of different factors. All of these factors are considered by the layout engine to determine the actual placement of items on the page. For example, the word auto here, the auto setting, means that the height for the row should be tall enough to accommodate all of the controls that are placed inside of it. If the tallest control is 150 pixels tall, or if the sum of all of the items are 150 pixels tall, then that's the actual height of the row. If it's only 100 pixels, then that's the height of the row. Therefore, auto means the height is relative to the controls that are inside of that row. The asterisk is known as star sizing. Okay, and it means that the height of the row should take up all of the rest of the available height, in this case, that's available. All right, so take a look at this little example that I put together before I recorded this video. Yeah, star sizing. And you can see what I've done here. I created a project that has 3 rows defined. So here I have 3 rows. And notice the heights of each one. I use 1 star, 2 star, 3 stars, or asterisks. Putting a number before the asterisk is basically saying, of all the space that's available, give me 1 or 2 or 3 shares of the remaining space available. Now, since the sum of all those rows, 1, 2, and 3, add up to 6, 1 star is basically equivalent to 1/6. 2 stars is equivalent to 2/6 of the height, and 3 stars is equivalent to 3/6. Okay, so therefore 3 star would get half of the height that's available, and so you can see that depicted in the output of this example, where the green is taking up roughly half of the available area inside of the content panel. All right. So besides auto and star sizing, you can also specify widths and heights as well as margins in terms of absolute pixels. In fact, when only numbers are present, it represents that number of pixels. Generally, it's not a good idea to use exact pixels in layouts for widths and heights because of the likelihood that screens, even Windows Phone screens, can have different dimensions. Instead, it's preferable to use relative values like auto and star sizing for layout. Now, one thing to note from this example and from our original Pet Sounds example is that control widths and heights are assumed to be 100% unless otherwise specified. That's why rectangles take up, as you can see here, the red, blue, and green rectangles take up the entire cell size. That's why the button, when we added it to the Pet Sounds app, occupied the entire content grid size. And that's why I wanted to specify the button to only be 200 pixels by 200 pixels instead. I want to also point out that a grid can have a collection of column definitions. Let's take a look at another project I created. Grid rows and columns. All right, and so here you can see, let me move this over a little bit. Here you can see that I've created a grid with 3 rows and 3 columns. So I define rows by using grid.row definitions to create a collection of row definitions, and then I add 3 row definitions to the collection. I do the same thing with column definitions, adding 3 column definition objects to my grid's column definitions collection. Okay, and then I simply just put a text block in each one of them. And so the result is that I have a simple grid with a number inside of each cell. The other thing that I want you to notice about this example that's pretty important is that when you don't specify the grid.row or the grid.column, it's assumed to mean the first row or the first column. So that's when as you see, I don't specify grid column or grid row, but one still winds up in this first cell in the upper left-hand corner. So relying on the defaults helps keep your code a little bit more concise. All right, I have another example here called alignment in margins. And so, as you can see, this XAML here, all right, we have a number of rectangles that I've created, different colors to help you easily pick them out. Most of this example should be obvious if you stare at it for a few moments, but there's a couple of finer distinctions that I want to make about alignments and margins. First of all, this example points out how vertical alignment and horizontal alignment work, even in a given grid cell. And the same will hold true in a stack panel as well when we get to that point. The alignment properties, so vertical or horizontal alignment properties, or attributes rather, pull controls towards their boundaries. So alignment attributes pull controls towards their boundaries, whether it be to the top, to the left, the bottom, the middle, or whatever the case might be. By contrast, margin attributes, left margin, top margin, right margin, bottom margin, or their shortened form as you see here, where I can specify all 4 attributes in a single string. Margins push controls away from their boundaries. So alignments pull towards boundaries, margins push away from boundaries. The second observation is the odd way in which margins are here defined, like I indicated a moment ago, as a series of numeric values that are separated by commas. This convention was borrowed from cascading style sheets. The numbers represent the margin pixel values in a clockwise fashion, starting from the left side. So if you see something with a margin of 10, 20, 30, 40, that means 10 pixels from the left boundary, 20 pixels from the top boundary, 30 pixels from the right boundary, and 40 pixels from the bottom boundary. A bit earlier I said that it's generally a better idea to use relative sizes like auto and star to define widths and heights for rows and columns. Why then are margins defined using pixels instead? Well, margins are expressed in exact pixels because they're usually just small values to provide spacing or padding between 2 relative values. And so therefore they can be a fixed value without negatively impacting the overall layout of the page. Okay, so next up we're going to talk about the stack panel, and it is the second style of layout that's enabled in your phone apps. It'll arrange your controls in a flow from top to bottom or from left to right. Typically from top to bottom, since we're dealing with phone apps. Back in our Pet Sounds project, so let me close all these guys down. So back here in our Pet Sounds project, we have the following stack panel created. It is basically to give us an app title and a page title at the very top of the main page.xaml. Both text block elements take up the entire horizontal width of their parent, the layout root grid, and therefore they're stacked vertically. So let's do this now. Let's convert our content panel from a grid into a stack panel just to see what will happen. So let's go down here and we're going to change from a grid to a stack panel, and we'll have to change the closing grid to a stack panel. All right. And if we were to run this app, the only thing that really happens, the only thing our conversion seems to accomplish is to move that meow button vertically downward. Now, let me do this. Let's stop the app, and what I want to do is remove the horizontal and vertical alignments. Or actually, let's just do this. Let me remove the width and the horizontal alignment from our quack button, and I'm also going to remove the this background and move this back to red. So we'll just set background color equal to red again. And let's go to the main page.xaml.cs, and what I want to do is just comment out the width and the horizontal alignment, and I'm going to comment out the margin as well. And furthermore, I'm going to comment out the height and reset it. So my button dot height equals 100, and I will do the same here by setting my play audio button's height to 100. And then I'm going to run the app again. And now you can see that the 2 buttons are stacked vertically in the stack panel. So as you can see, you can achieve just about any layout that you could imagine by using a combination of 4 things. Use a grid layout including row definitions and column definitions. You can use stack panel layout. You can use margins to move elements away from the left side, the top side, the right side, or the bottom side. Or you can use the horizontal alignment and the vertical alignment attributes to move items towards a particular boundary. Okay? So that's XAML layout in a nutshell. What I want to do next is move on to events. Now, if you watched the C# Fundamental series on Channel 9, in one of the final videos, we talked about events. In the Windows Phone API, pages and controls raise events for key moments in their life cycle, or they raise events whenever a user interacts with a given control or page. In this series, we've already wired up the click event handler of our play audio button with a method. So we navigate to the event handler, a method that I called an event handler. Now, when I use the term event handler, I'm merely referring to a method, just like we see here, that's associated with an event. I use the term wired up to mean that the event is tied to a particular event handler method. Now, some events can be triggered by a user, like the click event of a button control. Other events happen during the lifetime of a given control or page, like the loaded event that occurs after the page or the control object has been instantiated at runtime. All right? Okay, so there are two ways to wire up an event for a page or a control to an event handler method. The first is to set it using the attribute syntax of XAML. Now, we've already done this in our play audio button example. Remember this right here, okay? If you recall, we typed click equals double quote, and then before we typed in the closing double quotation mark, IntelliSense asked us if we wanted to select or create an event handler. Now, we told it we wanted to create a new event handler in Visual Studio, name the event handler using the naming convention, name of the element underscore the event name. So in our case, it was play audio button underscore click. Visual Studio also created this method stub in the code behind, in the .cs file version of our main page class. And keep in mind that these are Visual Studio automations. We could have hit the escape key on our keyboard and said, no, IntelliSense, we don't want you to handle this. We'll just do everything ourselves whenever IntelliSense first pops up. We could type all this in by hand, but honestly, that's a little bit difficult. I just let IntelliSense do its work. As long as everything's named correctly, I follow the convention that it wants to follow. That's cool. So the second way to associate an event with an event handler is to use the Properties window in Visual Studio. So, for example, let's get back over here, and I'm just going to put my cursor somewhere in the button and then go to the Properties window. And in the Properties window, by default, it shows the properties for the attributes for the item that we have selected. But there's also this little lightning bolt icon to the right-hand side of it, and when you select that, it shows you all of the possible events that are available for this particular element. So the name of the element will appear here at the very top, and that gives you the proper context for what you're going to be setting next. In other words, any settings that you make will be to this play audio button as opposed to something else on this page. If you were to double click a particular text box inside of this list of all the items that could be changed, then it will create an association between that controls event and a new event handler. Double-clicking will automatically name the event and create a method stub for you in the code behind. So just for fun, what you could do, let's just take loaded, for example, and I'll double-click loaded. And notice what happens. First of all, it adds this loaded attribute equal play audio button underscore loaded in our XAML, and then it also created this stubbed out event handler method called play audio button loaded. All right, and that was all just by going to here and then double clicking inside of here. All right, so let's go ahead and get rid of all of this because I don't want that. And you notice it when I removed it from the events tab of the properties window, it removes the XAML, but I'll have to delete the rest by hand. All right, so the third technique that we'll use several times in the series in order to wire up an event with an event handler method is to wire it up in C# code. So let's do this. What I want to do is take my my button that we've defined here, and I'm going to go my button dot click, and then I'm going to use the plus equal, and then you can see it'll give me a little hint here that I can use the tab button to insert a new my button underscore click event, and then I could tab once more for it to actually create that method stub, and then for me to start typing in that method stub. However, that's not what I'm going to do this time. I'm going to hit the escape key on my keyboard. I'm going to type in play audio button underscore click. All right, because that is already defined here in our code. So the plus equal operator can be used in other contexts to mean add and set. So for example, x plus equal 1 is the same as typing in x equals x plus 1. The same is true here basically. We want to add and set the click event to one more event handler method. So yes, the click event of my button can be set to trigger the execution of multiple event handlers all at the same time. So one click event could trigger one or more methods executing. Now in our app, I'd anticipate that only that this one event handler, play audio button click, would execute. You might wonder, why doesn't that line of code look something like this, with an open and close parentheses? Notice that the open and close parentheses on the end of the underscore click, recall from the C# Fundamental series that the open and close parentheses is the method invocation operator. In other words, when we use the open and close parentheses, we're telling the runtime to execute the method on that line of code immediately. But that's not what we want in this instance. We only want to associate or point to the play audio button underscore click method. Okay, so just to clarify, because a user had a question about that previously, and I want to make sure to make that point emphatically. One of the other interesting notes about event handler methods, with my addition of line number 35 in the code here, I now have two events both pointing to the same event handler method, play audio button click. And that's perfectly legitimate. How then can we determine which button actually triggered the execution of the method? Well, if you take a look at the declaration for the play audio button underscore click, there's two input parameters. The Windows Phone runtime will pass along the sender as an input parameter. Now, since we can associate this event with any control, the sender is of type object. Okay, it's the type that virtually all data types in .NET's framework ultimately derive from. And so one of the first things that we need to do is a few checks to determine the actual data type. Are you a button? Are you a rectangle control? And so on. And then we would cast this sender object to that specific data type. And once we cast the object to a button, for example, then we can access the button's properties and so on. All right, so that's how one event method could handle multiple events from different controls pointing to it. All right, the method signature in the code snippet is typical of methods in the Windows Phone API. In addition to the sender input parameter, there's also this routed event args type that's used for those events that pass along extra information. And you'll see how these are used in advanced scenarios. However, I don't believe that we're going to use them at all in this series, at least not that I can think of at this early stage. Okay, so to recap, the big takeaway in this lesson was the ways in which we can influence the layout of pages and controls. We looked at the grid and stack panel layout. With regards to the grid layout, we learned about the different ways to define the heights and the widths of rows and columns, respectively, using auto sizing, star sizing, and pixel sizing. We talked about how vertical alignment and horizontal alignment pull controls toward boundaries while margins push controls away from boundaries. Then we talked about the different ways to wire up events to event handler methods, like we just talked about, and the anatomy of event handler methods input parameters, like sender and routed event RZ. Okay, so at this point, our Pet Sounds project is working. However, because we run it right now, both of our buttons will quack like a duck, and it's not all that useful, right? Can you think of some ways in which we could correct this problem? It's actually pretty simple. We'll do it in the next lesson. We'll see you there. Thank you.